Good afternoon, I am Mr. Ish. We are looking here at a video on special factoring forms focusing primarily on these two, a cube plus b cube, a cube minus b cube. You could easily use x's and y's here if you wanted. Why are we focusing on these two? Because they're frequently confused with this. A plus b whole cube and a minus b whole cube. They're totally different, so don't make this confusion. We know this right here is a binomial, it expands. This right here is a factoring form, something which you can use to factor expressions and polynomials having that particular characteristic. So let's focus here on these factoring forms, particularly these two. Always remember a cube plus b cube is equal to a plus b and a square minus ab plus b square. This here particularly is equal to a minus b and a square plus ab plus b square. If you're going to, for each of these, do an opening of the parentheses and you did all of this, right, you would have intermediate terms that would cancel and you would only be left with a cube minus b cube from this, and from the top you'd be left with a cube plus b cube. Opening this up and looking for the items that can cancel out is a good time well spent, which you can do on the side on your own papers. Let's look at two questions involving these special factoring forms. Alright, our first question is 27a cube plus 1000b cube, and we have to factor this. We know here a will represent all of this, b will represent all of that, and these are perfect cubes. 3 cube is a 27, 10 cube is 1000, so a represents here 3a. Let's just call that a prime. B prime here represents 10b. And then now we're doing a prime cube. I'm only just doing this designation here with the prime so we don't repeat the letters, plus b prime cube. We're looking at something like that. And you know I've already given you the form would be basically a plus b, and you'll have a square minus ab plus b square. You have to put all of that into this particular format. Let's take this a and the b, the prime values, and send them through. We'll have 3a plus 10b, and then here you'll have 9a square minus 30ab. Remember ab would be 3a times 10b would be 30ab plus 100b square. If you were to do that FOIL technique, first out, inner last, and open all of this, you'll end up back right over here. And this expression over here, the polynomial factored expression, is correct. Let's look at this particular form. We're looking at 64a cube minus 8b cube. We're again looking at the special factoring form, which is a cube minus b cube. And you know what that is. That's a minus b into a square plus ab plus b square. Everything over here with regards to a and b will go through that. We'll just use again a prime because we have repeat or duplication of letters. A prime here will be what? This right here is a 4 cube. You'll have 4a. This here is a 2 cube. B prime can be 2b. Send everything through there. You'll have a minus b. You'll have 4a minus 2b. Here you create the next set of parentheses. You'll have a square, which is 16a square, plus ab. 4a times 2b will be 8ab plus b square, 4b square, and that will take you to your conclusion. Just as a quick test, if you did minus 2b times 4b square, you'll have a minus 8b cube, and I'm seeing that. If I did a 4a times a 16a square, I'd have a 64a cube, and I see that. And both of these answers, the one before and this, are correct. So keep the special factoring form in mind. Just do not confuse them for these other forms, the binomial forms. You have a plus b whole cube, and you know this is a cube plus 3a square b plus 3ab square plus b cube. Radically different than what we're talking about here in this particular video. A minus b whole cube would be a cube minus 3a square b plus 3ab square minus b cube. So these two are not the same as these special factoring forms that have been addressed in this video. And let's conclude this video with a good thank you and a bye to all of you watching this video. Have a nice day.